So far, we have learned about how to write the isotopic notation of an atom. But class, how do you write the isotopic notation of an ion? What do you need to include then? To do that, you have to understand what is an ion. Ion is an atom or group of atoms that has positive or negative charge, which are cation and anion. Cation is a positive charge ion formed when a neutral atom loses an electron or lose electrons, while anion is a negative charge ion formed when a neutral atom gains an electron. What is the difference between sodium atom and sodium ion? First, look at the number of protons. Both atom and ion has the same number of protons, which is 11. But what about the number of electron? For sodium atom, because it is an atom, hence the number of proton is the same as the number of electron, so it's gonna be 11 electron as well. For the sodium ion, the number of electron is 11. Okay, so this is Na plus, mean it loses an electron. Hence, 11 minus 1 would be 10 electron. Okay. See the difference? For ion, the only number that changes is the number of electron, and the same thing goes for anion as well. So let's take a look at the Cl or chlorine anion. Okay, so for chlorine atom and chlorine ion, the number of proton is 17. It is the same, but the number of electron for chlorine anion So for chlorine atom, the number of electrons is the same, 17, but for chlorine anion, it has the charge of -1. Hence, it gains 1 electron. So the number of electrons would be 17 plus 1, which is 18 electron. Example 4. Give the number of protons and electrons in each of the following cation and anion. Then you have to refer to the table of relative atomic mass to do this. But never mind, I'll just give you the number of protons. And remember that the number of protons will be provided in the examination, so you don't have to remember it. For K plus, the number of protons is 19. For magnesium is 12. Iron is 26. Bromine is 35. Manganese is 25. Carbon is 6. And copper is 29. Okay. So you just have to rack your brain to find the number of electron if you were given ion. Okay. So K plus, what does this plus 1 mean? It means that you loses 1 electron. Hence, the number of electron is 19 minus 1, which should be 18. For magnesium 2 plus, it means you loses 2 electron. Hence 12 minus 2 would be 10. Okay. I'll give you a few moments to do for the ferrum 3 plus. Did you got the answer as 23? That is correct. Okay, what about the Br minus? Br has the charge of -1, hence it gains 1 electron. So to find the number of electrons, it would be 35 plus 1, which is 36. Okay. You do it for manganese 2 plus. Yep, that is correct. It would be 25 minus 2, which is 23. Just do it for the last two. I'll give you the answer shortly after. Did you find the answer for carbon as 10 and copper as 27? Yes, both are the correct answer. See, now you know how to determine the number of electrons. Example 5, write the isotopic notation for each species. Okay. The first rule is to determine whether each species A, B, C, D is an atom or ion. Okay, so first rule, determine either atom or ion. Okay, again, take a look at A. The proton number is 2 and electron number is 2 as well, so it's just the same, means A is an atom. For B, the number of proton is 1, but the electron number is 0, so it is not the same. So B is an ion. Okay, you do for C and D. Yep, C is an atom and D is an ion, since the number of proton is not the same as number of electron. Okay, let's learn. I guess you already know how to write the isotopic notation for an atom, right? We already learned this before. And we've learned a lot of examples and exercise, so I just want to recap you guys on this. So the element is A. Sorry. Element is A, proton, the number of proton is 2, and the nucleon number is the sum of number of proton plus number of neutron. So which is 2 plus 2 equals to 4. Okay, we'll do the species B together. For B, the element is B and the number of proton is 1, and the nucleon number is 1 plus 2, which made up to 3. But look at here, the number of proton is 1, but the electron number is 0, means B loses and, or should I say it as 1, loses 1 electron. So if we lose an electron, so you're gonna have, is it positive or negative charge, class? Yes, you should be having positive charge. So hence the charge for B is plus 1. You don't have to write 1 for this. Alright, for C, it is easy. C, 1, the number of proton is 1, and the nuclear number is 1 plus 1, which equals to 2. So it is an atom, so it does not have any charge. So you'll do for D. I'm going to give you the answer after 1 minute. For D, the isotopic notation is D. The number of proton is 7. And the nuclear number is 7 plus 7, which would make up to 14. But what about the charge, class? So from 7, the number of proton is 7, while the number of electron is 10. So are you gaining or lose electron? Again, you gain 3 electron. Okay, so number 3, if you gain electron, so you should be having a negative charge. So D should have the charge of 3 minus. For now, we have learned how to write the isotopic notation of an atom or ions. So far, we have learned how to write the isotopic notation of atoms and ions. But do you know how we're gonna identify each isotopes that exist? So we're gonna use mass spectrometry in this aspect. So mass spectrometry is a technique used to determine relative atomic mass and the relative abundance of isotopes. So we can identify different type of isotopes because different atoms, isotopes or molecule can be identified by their specific or characteristic pattern of lines. So which means that each isotope has only one line. So look at here. So this line is specific for each isotopes. Meanwhile, mass spectrometer is the instrument used to determine the relative atomic mass and the relative abundance of isotopes. So, in short, I just want to highlight that mass spectrometry is a technique. Meanwhile, mass spectrometer is the instrument. I'm going to give you the mass spectrum of magnesium. So magnesium, the line of mass spectrum shows magnesium consists of 3 isotopes, which are 24 Mg, 25 Mg and 26 Mg. Okay. Just one quick question. I'm gonna ask you whether are these isotopes can be called as isotopic notation? What do you think? Is this how you write isotopic notation, class? So if I ask you to write the isotopic notation of magnesium, are you going to write it as this? That is no. Okay. Look at the example. It does not has the number of protons at the bottom. Okay, so this is not the isotopic notation for magnesium. Okay, but if the question just state if the question gave you like this, then it is fine. But if you answer it like this, 24 mg, 25 mg and 26 mg, then you are so dead wrong, because it does not has number of protons. So in order to read mass spectrum, you need to know that the height of each line is proportional to the abundance of each isotopes. Okay. So in conclusion, means that so each line referred to different isotope. Okay. For 24 mg, okay, so this is the correct isotopic notation. The abundance would be 63 for the 25 mg. The abundance would be 8.1, and for the 26 mg, sorry, I can't write on this. For the 26 mg, the relative abundance is 9.1. So which isotope of magnesium is the most abundant of all? You just need to look at the highest peak, which is this one. Okay, so the highest peak means it is the most abundant isotope, which is 24 magnesium. For the mass spectrum of neon, okay, I just want to highlight that relative intensity is the same as relative abundance. Okay, because for the first example, the y-axis is relative abundance, which is the same as intensity. So I want you to write the isotopic notation for all isotopes of neon right now. For 20 neon, there would be 19.2%. For 21 neon, that would be 0.26%. For 22 neon, that would be 8.82%. So which one is the most abundant isotope for neon? Yes, that would be the highest peak in the mass spectrum, which is 20 neon.